fact that I was going to be the first American woman to go into space carried huge expectations along with it. And that was made pretty clear just the day that I was told I was selected to the crew, because I was also taken up to Chris Kraft's office, who was the head of the Johnson Space Center, because he wanted to have a little chat with me and make sure that I knew what I was getting into before I agreed to be on the crew. But I was so dazzled just by the opportunity to be on the crew and go into space that I really don't remember very much of what he said. On launch day, there was so much excitement and so much happening around us. In the crew quarters, even on the way to the launch pad, going up the launch pad, looking up and seeing, this huge, rocket that kind of sounds like an animal. You can kind of hear the gurgling and the hissing, and, it sounds like it's alive. I spent an enormous amount of effort just trying to stay focused. I tried to block out pretty much everything that was going on around me and just kind of put one foot in front of the other, because it would have been way too easy to just be lost in the moment. I didn't really think about it that much at the time, because I just wanted to get the opportunity to do that. But I came to appreciate what an honor it was to be selected to be the first woman to get a chance to go into space.
When Sally Ride blasted off into space back in 1983,
liftoff of STS-7 and America's first woman astronaut.
She not only boldly went where no other American woman had gone before, at 31, she also became the youngest American ever in space.
I guess that I was maybe more excited about getting a chance to fly early than I was about getting to be the first woman.
The stars all seemed to be aligned. Ride was a PhD physics student at Stanford when she saw a help wanted ad in the college newspaper, an ad that would change her trajectory. It said NASA was looking for scientists to work on a new project. It also happened to be the same year NASA started accepting women into its astronaut training program. Of 8,000 applicants, 35 were chosen, 6 were women. And Ride was the one tapped to go to space on the Space Shuttle Challenger, prompting a flood of media coverage.
It's a real experience, and the experience of a lifetime to be able to fly in space and fly aboard the space shuttle. And I have to admit that I'm more excited about that opportunity than I am about being the, as you say, a footnote in history.
Sally Ride ultimately took the trip twice on the Challenger in back-to-back years. Her third flight was canceled after the disaster in 1986, but she went on to inspire young women to consider careers in science. Her example alone encouraged women everywhere to shoot for the moon.
I can't believe it was 25 years ago since we launched. That seems almost impossible. When that hatch shut, I realized, oh my gosh, this is really going to happen. The moment of ignition, there's absolutely nothing like it. There is so much power, so much thunder. You know that something you have no control over at all is happening for the next 8.5 minutes. There's rocket fuel that's in a controlled explosion beneath you, but yet the experience is just so new and so different that it seems like it's over in a heartbeat. The memories to me are as if it were yesterday. When the space shuttle's engines cut off and you're finally in space, in orbit, and weightless. And then I remember unstrapping from my seat, floating over to the window, and that's when I got my first view of Earth. Just a spectacular view, and a chance to see our planet as a planet, which very few people have the opportunity to do. I could see coral reefs off the coast of Australia, a huge storm swirling in the ocean. I could see an enormous dust storm building over northern Africa and then starting its way across the North Atlantic toward us. Unbelievable sights. I remember the first time that I looked towards the horizon, I saw the blackness of space and then this bright blue earth. And then I noticed right along the horizon, it looked as if someone had taken a royal blue crayon and just traced along Earth's horizon. And then I realized that that blue line, that really thin royal blue line, was Earth's atmosphere. And that was all there was of it. And it's so clear from that perspective how fragile our existence is. It makes you appreciate how important it is to take care of that atmosphere. On my second flight, we carried a variety of Earth-looking experiments. We were actually an Earth Sciences flight. And so I had the chance to use the shuttle's robot arm to release an Earth radiation budget satellite into space. And that's a satellite that was active for about 7 years monitoring Earth's greenhouse effect. And it was the first satellite to actually perform that function. We also carried a big radar with us in the payload bay that was studying land features, landforms on Earth and the surface of the ocean. So it was seismic features on Earth and getting some elevation and topography data. Several advanced successors of that radar have flown in space and have since given us the most detailed topographic 3D map of the surface of the Earth. And they've really revolutionized the way we're able to look at the surface of our planet. I started EarthCam back in the mid-1990s. We were able to put a high-resolution digital camera on board first the space shuttle, and then after a few missions, eventually on board the space station, where it still sits today. That camera is actually controlled by middle school students around the country from their classrooms. Their classrooms study earth sciences, decide what part of the Earth they'd like to photograph and when. Then we provide a website that allows them to do all the appropriate calculations, figure out exactly when the station is going to be going over that part of the Earth, and then command the camera to take a picture at that second. And we enable all this through a pretty darn sophisticated mission control center that we run at University of California, San Diego, and gives undergraduates a great work experience and opportunity working with engineers at JPL and at Johnson Space Center. And also, more importantly, I think, gives middle school students around the country an opportunity to take their own pictures of Earth and study Earth from space in a way that would have been impossible just a couple of decades ago. In the 25 years since my first flight, we've learned a lot about the planet. A lot of that knowledge has come as a result of our presence in space. All you need to do is take a look at some of the photos taken 25 years ago and compare them to photographs being taken by astronauts today or satellites today. What you see are very visible changes. You can see mountains that used to be snow-covered that aren't anymore. You can see glaciers that have disappeared. You see hurricanes that are more intense. You see these changes all around the globe. The key to global change is the word global. We're seeing it everywhere around the planet, not just at poles. There are some parts of the planet that are getting less water. They're going to be more prone to drought. There are other parts of the planet that are measurably getting more water. They're more prone to floods. It was technology that drove those changes. Our use of fuels, our ability to heat our homes and light our cities, has led to the increased CO2 in the atmosphere. But I think that now technology offers us the opportunity to develop solutions. It's the science and technology, as well as our own habits, that can really help us solve the problem that we've created for ourselves. I'm optimistic that we're going to be fine, but now is the time, and it's important to be starting. The next generation, the kids in school today, know a lot about climate change. They're concerned about it, they're interested in it, they want information about it, and they see it as a challenge to them to help develop those solutions, to help understand the science, develop the new technologies. And it's really true that the kids are so committed to this that it's making science and engineering cool again. So I think that the future of the planet is in our hands to help enable the scientists and engineers, technologists of the future to take on this challenge. We've caught on to the problem in time, and now it's just a matter of committing ourselves to the solutions. And the space program, space technology, is going to be critical as we approach this challenge of the 21st century.